Going into World War II, we had 45% global manufacturing market share. By 2000, that had fallen to 27%. China in 2000 only had 7%. China today, with WTO, most favored nation status, and our companies transferring process IP and manufacturing to China, now has over 40% global manufacturing market share. They are the arsenal of autocracy. We have fallen below 15% global manufacturing market share. So why did I start this company? I looked and said, we're never going to catch up to China by going back to casting, by going back to forging, by going back to stamping. No matter how much we automate it, no matter how much we add additive manufacturing to manufacturing casting molds, we needed to have a full end-to-end digital system. So over the course of the last 10 years, a team that's now about 500 engineers and scientists put together an end-to-end system called the Divergent Adaptive Production System. And before I go into that, I'll tell you what I think speed is. And obviously, many of you have much more background in the defense industry than I do. My background is having been an 0311 infantry rifleman in the Marine Corps before I went to graduate school and started doing all of the things that I'm doing now. Over the last 2.5 years, though, taking what we've built and applying it in the aerospace and defense sector, I've gotten an accelerated education. That education started when 2.5 years ago, I was invited by the global head of supply chain from RTX to come to look in Tucson at the Tomahawk line and to see the inability to source casting parts or to have casting yield over 20% yield of parts for these structures on our mainline missile systems. Flash forward, we now have a contract to re-engineer that system using our system as a fully digitally engineered system. What does speed mean to us? First, I'll say congratulations, Navy, as a Marine, on having defeated Army over the weekend. What I would say, though, is two things. In the last year or so, working with Air Force Armaments Directorate out of Eglin, we were teamed with a prime to do the world's first end-to-end, fully digitally engineered and then printed and assembled structure for an extended range attack munition that was air launched. The forward-looking PEO, Brigadier General Bob Lyons there, did something very smart. He looked and said to his people, we know you only have qualification for casting. Put together for a foreign military sale a qualification for additive manufacturing and this type of digital engineering. That happened. That system, within a year, was from whiteboard to flight test qualification, now to full volume production, was all done within a year. I'd say the structure engineered for that was done within 10 weeks. From T0 whiteboard to flight test was 10 weeks. We're now going into multi-thousand production of that system in 2026. We just, over the last 3 weeks, produced about 80 of those systems. That is not speed. I'll tell you what speed really is. I was at AUSA with Army, learned what the requirements were for their low-cost, long-range effects system that they were targeting. We took those, used IRAD, teamed up with another prime. 6 weeks ago, we took those from T0 whiteboard to flight test on Saturday at 9 Mile for a ground-launched long-range effects system. That was 6 weeks. We could now go directly into Q1 LRIP production, and then in Q2 do full volume production in the thousands. That is the speed that we should be working at, respectfully. And the Navy, respectfully, should be competing with the Air Force and now the Army in achieving that speed. And with that, I'll go back and explain now what Divergent is. So, I'd say from a structures standpoint, mechanical structures, warheads, without the energetics, the missile body, we integrate all the parts in, so we're taking several hundred parts of a missile body, fuel tanks, bracketry, fasteners, fuel lines, baffles. We print those all into the sections. So we take a couple hundred parts and reduce it to less than 10 parts. Wings, propulsion system, empennage, all of that is generated and printed by the system that we have. So those type of structures, we consider ourselves the world's most advanced mechanical structures manufacturing company, and do not believe there is anyone even within a generation of it. This system, which we call the Divergent Adaptive Production System, is a digital engineering and manufacturing system for land, air, sea, and space vehicles and components. The key thing, in my view, about having a system that leapfrogs the Chinese is capital does not want to go to casting because it's a lot of money up front on a product that you don't know what the real volume is going to be and even if it's going to be purchased. So there's a fundamental mismatch in a capitalist society between that business and where capital is going to go. You have specific tooling for a specific product. You have fixturing for a factory that assembles that specific product. We, from the start, did not look at any particular technology. People say Divergent is a 3D printing company. I could care less about any particular technology. You start with a set of objectives and requirements, you architect a system process, and then you build software and hardware to that. We design and build our own printers. We design and build our own assembly systems. The entire software architecture for that is coded within our business. That allows you to build a disruptive business, not any one isolated technology. So that system altogether, we call the Divergent Adaptive Production System. The key thing about it is it's no longer one factory, one product. Whether it's a mega factory that is building millions of individual things, each of those has the Achilles heel of only being able to build a single product or a variant of a product. Anything that we design on our system, any machine, and every single printer we make is this exact same printer, exact same software, hardware. Every assembler that we use is the exact same assembler, hardware and software. Anything we generate, any printer located in any factory, anywhere, can print and assemble any structure. So currently in our factory in Torrance, California, we are producing off of this exact same printers, 15 high-speed printers, and an assembly system, 450 different products. These range from complex auto products. We are a fully qualified Tier 09, Tier 1 supplier to Aston Martin, Bugatti, Ferrari, McLaren, Mercedes, AMG, and Porsche. Everything from gearbox cases to the crash structure, crash rails, bumpers, front rear subframes, suspension systems at real volume. And these are volumes that are much greater than anything you'd ever see in aerospace and defense. On the defense side, where we started about 2.5 years ago, we went from last year maybe having 2 or 3 defense contracts to over 30 today. We have over 30 active programs. So what does that mean? That means America needs not one factory, one product as an infrastructure chasing old technology and chasing China, which is not going to be a formula for success. We need fully digital engineering and manufacturing where any factory can produce any product. Those factories are distributed across the US. They're sized for whatever demand is. They can be scaled to higher demand when you add more machines, more printers, more assembly machines. And what does that mean in terms of elasticity? That means any variety of products can be built on any of these machines, and it means you can surge 100% of capacity in something as well. And I'd add another dimension to it, which is if you have a bottleneck in a certain component, like on a cruise missile system we were just doing, the major prime, their defense engine subsidiary could only produce about 800 of what was needed for about 300 systems. We then used 2 different suppliers of propulsion systems. Literally within days, we generated variants, and obviously the same machines can print and assemble these same systems. So it's not a cure for everything, but it is better, faster, cheaper, with a model that fits America, a model that fits American ingenuity, and the hope for this is that it builds something like Amazon Web Services built for going from analog to digital content, but does it for the actual mechanical structures, which is, it's that ecosystem infrastructure for many, many existing and new companies to no longer have the capital barrier and risk of setting up tooling of a product and fixturing of a facility. And that to me is the way that we go from the 51 primes that shrunk to 5 or 6 to having potentially hundreds of different primes and new suppliers of structures that tap into American ingenuity. So what do we do on this system that's completely in-house built? We take requirements. It can be for redoing an existing system like Tomahawk, or it can be for a new system like Co-Aspire's extended range attack munition that we just did, or the ground-launched long-range effects system. And then the system generates the structure, prints it, and assembles it, and we charge for that engineering, printing, and assembly. I'd say within defense now, we're focused on 3 areas. Legacy weapon systems, so those would be like the Tomahawk type systems, and I don't want to name the other names because they haven't been announced. Future weapon systems like the affordable mass systems. I'd say increasingly now we're also doing satellite buses and other space type systems. And then on the sustainment side, we've shown actually with all 3 services, our ability to, whether it's reverse engineering an existing part where there's been no bid for a long time, or getting even 2D drawings of it, we can take that within 24 to 48 hours, engineer that, we have a full test facility, test it, and then print it, and we can print in any volume that's then needed for one of those sustainment parts. And by the way, everything I'm talking about, if you want to see this online, there's sort of a decontented for confidential information and IP. But on YouTube, there's a video that's called Introduction to the Divergent Adaptive Production System. There's a lot on Divergent, so make sure you put introduction at the start of whatever search you do on YouTube. So Introduction to Divergent Adaptive Production System, but you'll see the whole end-to-end video of actual production of a system decontented and with some IP taken out of it. So, what's the result of this? Obviously, that speed. Cost, we right now are pricing at 20 to 40% below casting cost. So this is significantly cheaper at any volume than existing technology within the aerospace and defense area. And, for example, with a major, when you talk about better, with a major prime where we re-engineered their affordable mass cruise missile system, we, in the re-engineering of that, beside reducing the number of parts and making final general assembly much, much more simplified, by integrating those parts, we took out about 30% of the mass of the structure and increased fuel capacity without bracketry, and by printing in, increased the fuel capacity by about 40%. So that is the type of better performance you get out of these systems. And so what's the overall vision for this? The overall vision is to create a network across the United States of factories that are fully digital factories. They're basically, they can be different numbers of printers and assembly systems, but they're all the same printers and assembly systems. The factory builds those itself. We've created a 100% US bill of materials for that printer system, unlike any other system that is out there. And that system then would serve as an infrastructure for teams large and small, both commercial and in aerospace and defense, being able to build better, faster, cheaper mechanical structures for air, land, sea, and space vehicles. And with that, I didn't have a screen to show you the presentation on, or some nice videos we have, but with that, probably I've taken enough of your time speaking at you, and I'm very happy to answer any questions you may have. Oh, and by the way, I guess what people ask, why is that car outside? So the car that you see outside is the world's fastest production car. About 3.5 years ago, my son, Lucas, who's my business partner, he's also an engineer and inventor. The two of us are the lead inventors for the company. Between us, we have about 300 of the 750 or so issued patents that we've had over the last decade. He came and he said, Kevin, Dad, we have this platform we show Mercedes and Porsche and all these auto companies to sell what we're doing. You're always telling them they can be a CapEx-free, fabless design company in a completely new model for an auto company. Why don't you just build that and create an auto company? And so 3.5 years ago, we started a wholly owned subsidiary called Czinger Vehicles. If you go on YouTube and look at Czinger, CZINGR21C, you'll see it's recently been on the cover of Top Gear Road and Track Car and Driver. This car, unlike almost any of these, Mercedes AMG, Project One, Bugatti, etc., is actually fully homologated, meaning it passed every federal motor vehicle safety standard, full crash, full emissions, and is for sale and out on the road. And just recently, we took the car across California. We drove it over 1,000 miles in 5 days and set 5 track records in 5 days against the best that McLaren and Ferrari could show. So Sonoma, Thunderhill, Laguna Seca, Willow Springs, and Thermal, we crushed every single track record in a fully street legal American car. So now we can be proud that you hear of all of those legendary European racing brands, McLaren, Ferrari, etc. If you look on YouTube, you'll see there is now an American hypercar that has completely leapfrogged in performance what any of those companies have been able to do. So that's what that car's about. Questions? Yep. Go ahead. How are we going to do questions? I thought we're going to do the Q&A. Is there a mic?
Yes. Yes. Where's that
Rock
question?
and roll.
Adrian, unmute 7, 5, and 6.
Yep. I'll stand by. Testing. Good. Okay. General question is, well, first of all, Tom Alfaro, VTEL Logic. I'm going to start up with the drone. My question: what is your general response when people ask for a comparison between, say, carbon fiber layup, but weight from a weight standpoint, like carbon fiber layup structure versus additive manufacturing? Like, what is your general answer to coming out on top?
My general answer, and this is actually on the web, so if you put in General Atomics, Eaglet, and Divergent, is about 2.5 years ago, General Atomics reached out to us. They saw what we were doing in the auto industry.
Familiar.
They had about a 2-meter long unmanned aerial system, small unmanned aerial system. It had carbon fiber outer mold line. Even though we were replacing that with printed aluminum, because we were removing all of the bracketry, all of the subsystems, printing it in, we achieved about 5% less mass on that given system. So, it's not always going to be that, but that's a very real comparison. The thing I would say when they were looking at it was also, from a cost standpoint, this was massively lower cost. It was taking them to do that kind of layup about 12 days. These numbers are out on the web, which is why I can share them. I'm not sharing anything confidential. We were building them in 18 hours, right? Instead of 12 days. And we could do it at a fraction of the cost. And if you wanted to do a variant, we could do a variant. And, we had none of the tooling, fixturing, molds, nothing had to be created to do that. So I'd say that would be my basic comparison. And if you want to look into more detail on that, just do a search: General Atomics, Eaglet, Divergent.
Okay, thank you.
Hi, good morning. Thank you. Oh, sorry. Right here. Diego Padilla, Director of the California Space Cluster Space Return. Thank you so much for your presentation this morning. I completely agree with everything that you said, and that we need to transition legacy manufacturers into advanced manufacturing. My question is, what, in terms of validating materials to meet the specifications of legacy systems, for example, what have been your challenges, and which of our systems, legacy systems, do you think could more easily adapt into advanced manufacturing? Thank you.
I'd say what we did, obviously we went through it, so they're now, we're a fully qualified tier 1 supplier in automotive or land vehicles. On the air side, the approach that we've taken is, first on unmanned vehicles going one way, basically munitions. The first step was to take a munition, to re-engineer it the way we discussed with Co-Aspire and ERAM and Armaments Directorate, and then have that as the first step. So qualification, kind of rung of the ladder, number 1. It was a foreign military sale, and that helped on that rung. It was kind of a rung plus because it was an air launch system, that needed to be tested off a jet fighter within the US. So, it's actually an air launched system. I'd say the next rung on the ladder, we're looking, on the Army side for this ground launch system. that's going to be for not foreign military sale, but obviously U.S. use, and do the qualification and have that qualification standard. I think the key thing then is to have that qualification standard, which is for if anybody wants to do what we're doing, if they're doing additive manufacturing and they can achieve our materials quality or scale or cost, great for America. We welcome that, and we're obviously super competitive, and we welcome any competitors to try to come out on the playing field. So then, the next thing really is you're moving, and that's something we're doing in a program that's about a year old with AFRL plus the different service branches and NASA and the FAA, which is really qualification on manned aircraft. So that is kind of the sequence that we're going through. I think what people know now 100%. So on our machines, we have 3 different sensors that basically real time on every 100 micron layer of what we're printing, no defects, distribution, voids. That's how we're getting basically 100% yield, and know with all of that data what the quality of the structure is. That is, if you talk to, say, somebody like Triumph Group, where we're doing gearboxes for jet aircraft landing gear, gearboxes for rotary wing vehicles. These are also foreign military sales. The quality and difference between what we're doing and a casting, is a universe apart, right? We have, super good material quality, and the only way you can do that is upfront. And I'd just say, I've raised over $1 billion over 10 years to build a company, is by incorporating a metallurgy team from the very start of the company into that overall multidisciplinary team. Don't be scared, please.
Good morning. First of all, thank you for your service.
Thank you.
I agree with a lot of things you said. My name is Sandy Nasseri. I'm a business owner and system integrator in Hollywood. I agree with you about Foxconn and Apple and Tesla. My question to you is, the reason why Apple went to China is because we don't have enough engineers. And you are proudly employing 500 engineers, which is an achievement for business growth, for you to grow in other parts of the country. How do you foresee yourself employing, hiring, partnering with schools to actually groom the next generation that comes to be able to work for someone like you who's innovating and successful and US made moving forward?
I mean, we have had for a decade a very active internship program, and we work very actively primarily with Cal Berkeley, Cal Poly, and Caltech. And so, at that level, we bring people in. What I would say is that manufacturing in the future, jobs that are going to be created, just like you go back to when Amazon Web Services was created, right? At that time, if I was building a software company, which I did in the late 90s, you were having to create your own tools as a developer. Then you were having to set up your own server factory, right? You had real CapEx, real time, real money. Amazon Web Services came along, and all of a sudden they were saying, we'll give you a set of design tools, and we'll give you on-demand processing and storage capacity. And all of a sudden you develop hundreds, and then thousands, and then tens of thousands of developer teams. When you have automation like you have now for manufacturing, and this is not a vision anymore. I mean, this is happening. We're producing ERAMs and other missile systems in this coming year, right? This is full on being delivered. We're delivering to Aston Martin and Bugatti and McLaren and Porsche and Ferrari, et cetera, right? This is reality. You don't need many people to actually run these machines. That is the truth of it. What you do, though, is once you kind of distribute that and what we're doing in the next 2 years is we're not going to have our structures group do the inputs for somebody's set of requirements, but we're going to push those tools down to people, teams that can then use them and have it printed and assembled locally. Then it's my belief and wish we're going to create tens of thousands of new product companies. We're going to have not one Anduril, but dozens, because the barrier to entry, the capital barrier, the time barrier will disappear. And those will be much more fun jobs. They'll be like when I was growing up in Cleveland with my 2 older mechanic brothers and building cars. You'll be building real stuff and seeing it, not, and I worked summer labor in Cleveland in a steel mill, right? Not doing the same work, shoveling coke back up onto a conveyor belt, for 8 hours at a stint, right? I mean, we can create a much more vibrant builder culture. I believe there is absolutely no reason, except for lack of will, for us not to do it.
Sir, John Harrison from Phillips Corporation. We run the Additive Manufacturing Center of Excellence for the Navy down in Danville, Virginia. You made a strong claim of savings of 20 to 40% over traditional castings in the sustainment market, and we have.
I'd say in the new missile body, existing missile body. So
Okay.
I'd say versus a Tomahawk casting, for example.
My question, sir, is we haven't been able to achieve that, and it's pretty amazing, and I believe you. Is it mostly through redesign, or is it through your production system you're able to achieve those types of savings?
Yeah. I'll be bluntly honest with you, and I want the entire additive manufacturing industry to grow. But these are companies that created a machine and then said, what are all of the applications that we could apply this machine to? Everybody in Silicon Valley knows, that is the fundamental way not to build an industry. When you do that, there's a term for that. It's called half invented, right? Like you've invented something, but you haven't said, what am I actually trying to do? I'm trying to create an end-to-end design agnostic system, and printing is just one component of it. And how would I know how to build that system if I start out with something and then try to reverse engineer the system against something that was never designed for that system? You have to look at, for example, the standard aluminum, 10 mg, high silicon aluminum, right? You're never going to get the productivity, the cost, the rate with that as the standard material. You can't take a casting material when you have a different set of process parameters, and you need to, and I can't go into RP, with process parameters, control every single one of those process parameters against the, alloy makeup for a specific set of requirements. Say you're trying to do a high ductility aluminum for the crash area of a vehicle. The elements, the processing power that you use, the testing that you use, the makeup, the morphology, the particle distribution, all of those are elements that you need to control at the system level in order to achieve this kind of cost productivity. I mean, when I started out, the first, printers 10 years ago were printing about, if you're talking about reality, right? Not somebody printing a block of metal, it's crap. If you're looking at some real production, you're talking about 10 to 20 milliliter an hour production, say for an aluminum that's about 2.7 grams per milliliter, right? So you're doing 50 grams of material an hour. We're doing over 2 kilograms of real net effective print rate for aluminums. Now, that only happened by spending almost $1 billion, having the full system, creating printers where 3 years ago I was getting up at 5 a.m. every morning running the first half dozen printers and then figuring out what the next version was, and real-time making decisions, right? And instead of, oh, it's a printer company, you talk to their sales rep who then talks to their R&D, who then their R&D actually says, oh, we actually got that from another supplier, who talks to the sales rep. No, that would take a decade to get there. And I don't mean to be negative, I'm just being bluntly honest with you, and please forgive me for that.
Thanks, sir.
Hi, I have another question for you. So you fundraised over $1 billion. What is the thing that is attracting your investors, or what is the, because we obviously all see the value of what you're saying, and when I speak to certain investors, I feel like they don't see it. What is it that they're not seeing, and why aren't they rushing to support this instead of, some of the other things that they're rushing to invest in? Thank you.
Well, the reality is I did raise over $1 billion, or I should say we. As my wife always say we. And by the way, my son is my partner in the business. So I'd say the reality is you don't raise over $1 billion without having someone think what you're doing is absolutely compelling. I mean, if people get in the end, if you are able to create, which I believe we now, there's no technology issue with it. It's really an adoption issue and how fast we can scale, not whether the technology is commercialized. It is. I think, investors get, if you can do an AWS, not for analog to digital content, but from analog world to fully digital structures, that is massive transformational system, right? That has elements I haven't spoke about. For example, like on our aluminum side, these are all elements that can be closed loop recycled. So imagine, at the end of whatever is the design life of a structure, you re-atomize it and reprint it as something. You're taking out the energy and emissions from mining, from processing, et cetera. You're creating structures 20 to 40% lighter, therefore they use less electricity to power them or less fuel. It creates a system that is in harmony with nature. It also creates a system that allows our young generations to be creative, not to think, okay, I've got to, join some gigafactory company that, is like one huge thing stamping out the same things. Like small teams can create many things, right? Like 1,000 flowers bloom, but in really creating things. And to me, kind of that's a cool vision. And I think I just did I went to raise our kind of last quantum of capital, which was about 150 million. We had over 300 million of demand and closed on 300 million. I'm trying to think back in September, right? At a multiple of what our valuation had been. So, the company's got a multi-billion-dollar valuation.